Greetings again. This is Kami coming to you from downtown Kingston. Hoping that you've had a grand day and that your plans are going accordingly, and hoping that you are following my email communications. Today, we're going to turn our attention again and talk about breathing. Breathing is the key to sustain life. A protective mask, the C4 respiratory mask, which all of you are familiar with, plays an extra critical role in preservation of life in challenging chemical warfare agent environments. The mask, if I can call it that collectively, is made of two components: the face mask or shield and the cartridge, which is visible in this picture. And I'd like to mention the three letters CDN standing for Canadian, which is the result of more than half a century of perfection and striving to produce the best protection by our defense scientists for the troops. So let's look at the face mask first. Well, the first face mask, folks, is made out of a very sophisticated synthetic rubber, an advanced silicone that is resistant to a large array of chemicals, oils, lubricants, and fuels. And it keeps that resistance intact up to a temperature of minus 20 C. But the most critical part of the mask is the C7A filter cartridge. In that cartridge, the first line of defense is the high efficiency particulate air or HEPA filter. I'm sure you have come across the word HEPA filter before. It has the capability, and a good capability, of filtering out larger solids and aerosol droplets that may not be visible to the eye. But the main fortress of defense is the compartment in the back housing the activated carbon bed. What is that? It's an advanced defense against a large variety of chemical agents in the form of gas and vapor. It filters those chemicals out in the form of gas and vapor. But what is this activated carbon? Let's look at that together. Activated carbon is a super purified charcoal made from, yes folks, coconut shells and soybean nutshells, and is treated to exact physical and chemical conditions to generate very highly porous structure in the nanometer scale. What is a nanometer? 1 nanometer is 0.00001 millimeter. Simply put, the size of a molecule. During this physical and chemical treatments, which is called activation, metals such as silver, copper, magnesium, and zinc are added to this structure, to this porous structure. These metals carry a positive charge and act as large magnets, attracting many chemical agents. Folks, in that canister you have much more than a gram of activated carbon. I want to present you to the fact that 1 gram of that activated carbon, because of its porosity, holds a 1500 square meter surface area. What does that mean in simpler terms? How about 7.6 tennis courts? That's for 1 gram. Or 45 generous parking spots. Yes, folks, that's 1 gram, and there's more than 1 gram in there. Let's look at this activated carbon to see what it looks like. This is your highly purified piece of charcoal from a coconut shell. Let's zoom in, and you can actually see the beginning of that porous structure in this close-up. If we use a scanning electron microscope, you can get a better vision of that pore, of those pores, or the porous structure, I should say, of the activated carbon. Let's zoom in with a scanning electron microscope, and you can see the extensive porous structure of the activated carbon that will allow such huge surface areas in such little carbon. Folks, at this time I would like to bring your attention that 2 giants at RMC, namely Colonel Sawyer, yes, Colonel Sawyer, you've been in that building, Sawyer building, and Professor Jack Dacey of Chemistry and Chemical Engineering, were the pioneers of activated carbon science. Yes, activated carbon science. Colonel Sawyer was the chemical warfare officer in the First World War for Canadian forces. And 31 years ago, when I came to RMC, I had the pleasure of having many conversations with Professor Jack Dacey of Chemistry and Chemical Engineering Department. Yes, 2 giants of activated carbon science coming from RMC. So let's look at how this porous structure that is impregnated with these metals actually work. So you have an activated carbon bed. You appreciate that term now. The chemical warfare agents are adsorbed at molecular level. In other words, they are just coming in and physically attaching themselves to this structure. Let's look at this. So there are your pores, and they are your typical organic molecules, the size shown proportionately, sitting in those structures and being adsorbed, meaning physically attracted to those porous structure, or trapped, if you will. But here is when this activated carbon science emerges. If you have chemical warfare agents like the nerve gases and mustard gases that have a very low vapor pressure, in other words less than 10 millimeter mercury, they have an electrostatic attraction to those metals and give you a long protection. The other chemical agents, blood agents, and phosgene, HAC and Cg, they have a high vapor pressure. That means they're volatile. These agents will have a chemical reaction with activated carbon. And activated carbon has a very limited capacity for that chemical reaction. Therefore, your protection is limited to 30 minutes. In the video that I sent you in the Anthrax Island, the people that visited those Russian labs, abandoned Russian labs, were reporting that their filters were being jammed in and about 15 minutes because of an incredible array of chemical agents that were poured in those trenches in order to deal with anthrax. Now, in addition to what you just heard, we talked about the Horizon 1 suit. And the middle layer, yes folks, also holds that activated carbon layer that now can absorb the chemical warfare agent vapors. We talked about that yesterday. Now you are better familiar with that process of absorbing the chemical warfare agents, but allowing the air in and sweat out. Are there limits? Absolutely. Filters do not supply oxygen. Goes without saying. If they are inundated with large amounts of water or humidity, they are not as effective. Here comes the very critical point. The filter does not give protection against tritium, carbon monoxide, ammonia, and very light paint solvents. All those chemicals, folks, have one thing in common: low molecular weight. Very low molecular weight. They, because of that low molecular weight property, can penetrate the porous structures and get through and cause a lot of harm. They have all in common, I repeat, very low molecular weight. Thank you for your attention. Hope to come to a theater near you very soon.